Hi, my name is Christopher Gill, and this is my AWS Elastic Transcoder presentation for my final project for CSCI E90 Cloud Computing at the Harvard University Extension School. Through today's presentation, I'll go through several key areas, primarily discussing what it is, what you can do with it, how much does it cost, as well as some technical limitations. And then finally, I'll go over my personal final project where I had to develop something based around the AWS Elastic Transcoder. So what is AWS Elastic Transcoder? In Amazon's own words, it is a media transcoding service in the cloud. It is designed to be highly scalable, easy to use, and cost-effective way for developers and businesses to convert media files from their source format into versions that will play back on devices like smartphones, tablets, and PCs. It is one of the suite of Amazon's web services, cloud services, and is available both in free tier and pay versions. I'll go over more details as we go through. At the cornerstone of Web 2.0 is the ability to disseminate rich media across the globe to varying users and varying network topologies. Amazon's Elastic Transcoder gives you just such a toolset to accomplish that. One of the key use cases involved with Elastic Transcoder is the ability to take a single source file and convert it using Amazon's highly scalable infrastructure into output formats that correspond to the most popularly used mobile devices around the globe. Not just mobile devices, but also home theater systems and things with larger screens as well. Really giving you an end-to-end system that can design for any screen you need to play your rich media back on. A second, smaller but still important use case is for small and medium businesses. Many of these companies have training and instructional videos that they must disseminate to their employees on a regular basis. Elastic Transcoder allows them to standardize those videos and then host them using Amazon's web services quickly and efficiently, minimizing the cost to distribute and achieving a much higher viewing rate by being able to audit who has viewed what video. While not strictly topical to Transcoder, I do believe it's a key use case that Amazon relies on. The third and the most grandiose vision of Elastic Transcoder is in the big streaming category. These are companies we all know: YouTube, Netflix, Vine, companies that make a living streaming video from their servers to your home in any screen and format you want it. The ability for them to have a quick transcoding mechanism that is extremely scalable gives them the ability to reach a wider audience at a lower cost than they could do by themselves. So we've talked a little bit about how it's used and the use cases, but we need to know a little bit more about how it works. At its core, Elastic Transcoder is essentially a queuing mechanism. You set up your queues, known as pipelines in Transcoder world, and on either end of them you have Amazon simple storage buckets that allow you to upload files, feed them into that pipeline, and get out the other end the format you wish. The process of actually converting one of these files is known as a job. And because of the ability to scale across many pipelines, as well as have multiple jobs run in parallel within a single pipeline, Amazon is able to achieve massive throughput of video transcoding, as well as audio. Beyond the obvious of being able to take one video or audio format and convert it to another, there are several other smaller features within Elastic Transcoder that I think warrant mention. Watermarks, thumbnails, and clips all provide you the ability to view your files in a different way. Watermarks preventing piracy and illegal use. Thumbnails and clips allowing you to have smaller versions or just screenshots of the video so that you don't have to open it up the entire thing and waste all that bandwidth just to see what's inside of it. Beyond that, you can add captions for things like hearing impaired. There are also metadata fields that you can add to the video to enable indexing and things of that nature. One of the more modern additions is adaptive bitrate streaming, allowing you to stream media and have it automatically decide what the best bitrate is for sending to that particular client based on their device and their bandwidth. We'll talk more about that one later, as it is a central focus of my project. Additionally, you can create playlists and encrypt your videos if you need to. So why did Amazon go through the trouble of creating Elastic Transcoder? primarily because transcoding is traditionally a highly compute-intensive task, but also one that doesn't happen every day in many companies. Therefore, you end up with a lot of quiet time on very expensive hardware. The centralization that cloud provides, as well as the standardization of providing it as a service, helps distribute those unused resources more efficiently and save your business cost. Beyond that, highly skilled people in video and audio codec support are hard to find. It's a very esoteric field of knowledge. Very few highly trained encoders on the market means that not everyone has access to the best of these services. Again, centralizing and providing it as a service allows those highly skilled resources to be able to better distribute their knowledge, as well as aid us all in faster uptake of technological advances in the field. Lastly, video and audio encoding software is notorious for security flaws. Spyware and malware run rampant. And because of that, the industry as a whole has lost a lot of trust. Amazon brings their highly reputable service as well as a secure platform into the mix and allows you the peace of mind to encode your videos as you need. So we've talked a lot about what you can do with Amazon Elastic Transcoder, but what does it cost to actually use it? The numbers are a little bit variable by region, but however they're very small in general, and so really the difference is negligible. General consumption is charged by the minute of video or audio processed, and there are different rates depending on whether you're doing audio, standard definition, or high definition. Those are the costs that are directly attributable to Elastic Transcoder. However, I like to warn people that there are hidden costs to Elastic Transcoder as well, due to your requirements of having to use S3 storage to house the files before and after transcoding, as well as the bandwidth required to get the files in and out of Amazon Web Services. These are hidden costs that should not be ignored, especially in large deployments. However, on the whole, if you're just doing small bits of transcoding here and there, Elastic Transcoder can certainly save you a lot of money right off the bat. Well, we've talked a lot about the great things that Elastic Transcoder can do. There are a few limitations that you should be aware of. For example, a single account can only have 4 pipelines at one given time. Now granted, those pipelines can host between 12 and 20 concurrent jobs, so that does come out to quite a few concurrent transcoding jobs. However, it is a limit to be aware of. The maximum number of outputs you can have per job is also a limit. Because there are so many presets, you could conceivably create hundreds of output files per source file. Thereby, Amazon has limited your outputs to 30 per job. Additionally, there's a maximum rate at which you can submit jobs, both for creation and reading. 100 requests per second are allowed, which is a fairly substantial rate unto itself. And there's really no reason you should have to go over that. However, as with most of Amazon's services, all of these limits are flexible. Discussions with an account representative at Amazon can yield you higher limits should you represent a significant business proposition to them, as well as a reasonable use case for the usage therein. Well, there's certainly an API for just about everything within Amazon's Elastic Transcoder. It's very hard to demonstrate APIs and keep people's interest. Therefore, we're going to briefly go through the console view of Elastic Transcoder instead. The screen you're seeing now is the basic inputs for creating a pipeline. Remember, the pipeline is the queue that you're feeding jobs into and out of. Basically, a pipeline has a name, as well as input buckets and output buckets within S3, those being where the files are coming from and going to, respectively. You can also grant permissions around those buckets, the files that are assigned to those buckets, as well as one nice feature is the ability to tie into Amazon's SNS messaging system that will allow you to be alerted of any changes to your jobs as they flow through your pipeline. For example, if one fails midstream, it will send you a failure notice and you can quickly resume the processing. Once you have a pipeline defined, you can start feeding it jobs. A job is essentially you feeding it a media file, audio or video, and giving it a set of parameters by which it's going to transcode that file. There are a whole bunch of presets, so many so that I can't even fit them all on the screen. And basically you're going to stick to using those. However, if you did ever need to, you can create manual versions of these too that have much more fine-grained controls on them. Beyond the ability to select a preset for your transcoding, here is where you would define whether you want thumbnails, clips and captions, watermarks, as well as any playlists and encryption of the input and output files. Once you have a job processing, the console output can be very helpful in determining where things are. As you can see, there are statuses assigned to each subtask within a given job, as well as to the job on whole. These tasks can be relayed through SNS onto your personal mobile device or an email account as needed. Beyond that, though, here's where you'll find warning details, error messages, as well as just summaries of what you've asked Elastic Transcoder to do. It's a handy bird's eye view of your processing job. At this point, I've told you pretty much what Elastic Transcoder does. Now I'm going to switch gears a little bit and start talking about my personal final project as it relates to the CSCI E90 course. For my project, I wanted to try and set up a media streaming service. Similar to Netflix, I gave it a funky little name called Miniflix. As with any application, it was important to storyboard the features that I must have, need, and want. For this, I put together several storyboard slides, which I'll go through briefly now. On the must-have side, basically users need to be able to upload a video and get something out the other end, whether a link to their streaming video, or ideally, maybe be able to stream the video directly from the link. We'll talk more about that later. For the things I wanted to try and include, these were things more related to making the user experience more friendly. I didn't want to hold up the user's browser, so I wanted to be able to do as much processing in the background as I could. Transcoding, system uploads, and things of that nature I was hoping would not have to interfere with the user's browser experience and make them wait. Additionally, I really wanted to focus on adaptive bit streams. We talked a little bit about that earlier, but essentially what it is new technologies that allow the stream of video itself to determine the correct bit rate for the client it's sending to. But beyond that, it's able to switch on the fly, midstream, pardon the pun, and determine the correct bit rate for any given moment. So as your bandwidth ebbs and flows, it can change the video quality that it's sending to you. This can be hugely beneficial for enterprise systems where bandwidth can be a major component of their cost to driving entertainment to your home console. Additionally, I wanted to make sure that we weren't being inefficient. I wanted files to go directly into S3 rather than my server becoming a bottleneck for the transfers. This turned out to be one of the harder aspects of the project. However, once achieved, I do believe it sped up upload and download times by up to 50%. Beyond the things that I was going to try to have, there were a couple nice ideas that rattled around in my head that I figured if I had the time and capabilities I would try and put in there. Most of these didn't end up coming true, but that's okay. Primarily these revolved around UI type decisions, basically making it look elegant. Anything that looks better is more likely to attract more users. Additionally, I wanted to add basic validation, things like not allowing duplicate videos, as well as packaging the system as some kind of container for easier deployment. That would have been a lifesaver in preparing my final demonstration. Beyond the features, there were several experimental ideas or hypotheses that I had in my mind going into this project, some of which I thought I might be able to explore further through the execution of the project. The primary one was my adoption of Rails. I've recently started to learn Rails, and I wanted to see if it was really ready enough to make a proper web application quickly and efficiently. The short answer is no, and I'll talk about more why later. Some of the other ideas I had in my head also proved to be wildly wrong. I wanted to know if Beanstalk could manage the entire application, tying a little bit to that idea of containerizing my application somehow. I didn't even get to try this one. The middle one, Apple's codec, HTTP live streaming, HLS for short, is one of the newest codecs added to Amazon's bevy of presets, and so I wanted to take it out for a spin and see if it could really work beyond Apple devices. Again, the answer was absolutely not. After coming up with all the requirements and ideas, it was time to design the actual solution. Here I opted for my Ruby on Rails front-end web server with two S3 buckets, one for the input and the output as we've talked about before, as well as a SNS queue to handle messaging between Elastic Transcoder and my web server, allowing me to provide real-time updates of the status of processing to the users who are uploading their files. I had a MySQL database on the web server itself in order to handle archival of that information, as well as track the streams and things of that nature. I also had a Redis database on here to briefly play around with the idea of asynchronous transactions. I ended up not using Redis too much, however it was still there in the end, so I left it on this slide. My Miniflix web application starts out with an index page. It sure is ugly, but at least it was functional. Here, you're presented with the major functions of the website. First in the top right is an upload a video button, allowing you to add a new video to the site, which would then be handled by Transcoder, creating a streaming version of that video. Below that is a play button, which would take you to a screen that I would hope would present a browser-based play of that video artifact. And then lastly, there's the delete button, in case you put something out there that you don't want and you want to get rid of it. I'm a big fan of allowing users to delete their data. Another nice feature was the red, yellow, green light for as the file was processing. Handled by the SNS topic I talked about before, Elastic Transcoders could send messages directly to my web application, allowing me to update that status icon in real time as the job flowed through the pipeline. Lastly, all of the relevant links for your media were presented here to you. The thumbnail URL I didn't use, but I had hoped to present it as a picture. The stream URL is the URL that you can actually plug into your desktop player and be able to stream the video. The source URL is the URL to the file you uploaded to us. And then the prefix and name are kind of organizational parameters that are used to track where the file is located within simple storage. The first action you're likely to perform beyond the index page is to upload your own video. The upload form was also quite ugly, however, still very much functional. I didn't have time to add a status bar to it, unfortunately, so in the case of uploading large movie files, you can sit there watching the browser window spin for quite a while thinking, is it working? However, one of my prouder accomplishments of the project was my ability to get this page to relay files directly to the S3 bucket without having to hop through my server. As I mentioned earlier, I think this saved me about 50% copy time during uploads. Basically, it gave the end user who is uploading the file a direct link from my web application to the S3 bucket, which that file is then transmitted over. I don't need to save it onto my hard drive on the server. I don't need to cache it. It just goes directly to the S3 bucket. The play page, for once you've got your file back from Elastic Transcoder, was kind of a failure to launch. I tried several different JavaScript-based media players. None of them would play the latest Apple HTTP live streaming broadcasts. I did see one that I really do believe will work. However, at a cost of $300, I could not add it to this project. Beyond the video streaming player itself, though, this is another view, perhaps a more friendly one, where you can see the relevant URLs and details about the file you uploaded. I mentioned that the browser-based media player was a failure to launch. However, I was able to get my media streams playing from my desktop, In this case, you can see in the menu bar of VLC Media Player that it's playing the file directly from Amazon S3. No caching, no downloads to my server, just straight from the bucket to you. I say it works, but it really was very painful to get it to work, and it never really worked 100%. This is largely attributable to Apple's HLS format and my having Windows systems across the board. I do believe that in time Apple's HLS format will become more of a standard and easier to play. However, at this time, with it being fairly new, it's still fairly limited to Apple and iOS devices only. After so much failure, I did want to make sure I got one thing absolutely right: the delete page. This one works like a charm. You simply click the delete video button and it's gone. So what did I learn across this project? Probably the first thing is, pick a smaller project. I'm not an expert web developer, and for some reason I thought I could build Netflix in a couple weeks. This turned out to be fatally flawed and led to a lot of late nights leading into project deadlines. More pertinent to the topic of Elastic Transcoder, as we've kind of been off that topic for a little while now, you've noticed, is that it's a very mature product. It's extremely easy to use, fairly bulletproof. I wasn't able to really break it through my whole course of testing. And it's exceptionally fast, much faster than my home PC, and I do have a fairly nice home PC, could ever transcode those videos. All of this led me to have a lot of faith in Elastic Transcoder's ability to be the cornerstone of a truly enterprise or global scale system. Speaking of global scale systems, Ruby on Rails is not it. I do believe it'll get there one day. However, right now there simply isn't enough community library development. Things like the direct S3 upload I mentioned just aren't there on their own, and you're left developing a lot on your own, whereas many other web frameworks tend to be much more plug and play. I do like Rails' ability to plug things in and play them once you have them designed. However, the community just hasn't developed enough yet to have all the core functionalities that so many other web developers haven't coded in 20 years. They just pull the library down and import it. Rails will get there one day, but it's not there yet. Beyond that, in all my tinkering with Elastic Transcoder and trying to find various different codecs and things of that to play with, I did notice that format wars are still a thing. I really thought they had kind of died with the death of Blu-ray versus HD DVD. However, they do seem to be alive and well in the web streaming world. Apple's HLS doesn't play on Windows. In fact, it doesn't play on Linux either from my tests. There are fringe exceptions, but by and large that's true. Microsoft Smooth Streaming, on the other hand, isn't particularly conducive to playing on Apple. Its tight integration with Silverlight makes it hard to play on Apple. The open alternative, MPEG-, supposedly the savior to all of this, is so great that the developers can't stop arguing over it long enough to actually release it. And so Amazon has yet to release a transcoder for it in Elastic Transcoder. I'm fairly confident once they do that this will become a standard across the globe. However, I don't think that's going to be anytime soon. Lastly, there's the has-been. Adobe Dynamic Streaming for Flash. Kind of everyone hates them now because of Flash's inability to play on most small devices. So the format wars are still a thing. But beyond that, there were some really nitpicky things within the AWS API that drove me nuts. SNS developers, I hope you're all listening to this, because the parsing I had to do on some of the messages coming out of SNS was unreal. You've nested hashes inside of JSON, inside of serialized hashes, inside of more JSON. And the parsing was quite a nightmare. Other than those minor things though, even though they did take significant time, the APIs on whole are very well thought out, and in fact, I can see trails of them getting much better in the years to come as they move to a more resource-based approach. Maybe that's a project for next year. Anyway, I appreciate your time in listening to my final presentation, and I look forward to meeting you all sometime in the future.